So what we're going to do today is we're going to do this question. I basically took care of the hard parts of this, so we're going to go ahead real fast and do the steps that we put in yesterday. But real quick, just so you guys know, I took care of the free body diagrams for you, so we don't have to waste time on that, right? But we are going to go through them though. Okay. So this is the problem we're working on up here at the top, right? So link 1 is the ground, link 2 is this Revolut link, link 3 is this very strange slider hook to rollers, and yeah, you see it, this weird looking one. And then you have 4 as this roller and 5 as that roller. Okay? And before we get started, like I said, we're going to go and do the steps to solving really fast. Alright, so steps. Alright. Probably turn that down just a little bit. Alright, so steps to solving first analysis. Can anybody tell me the first one that we have to do? From yesterday. I know most of you were here. Break the links. Yes, so break them apart. So break apart the links. And that's sort of what we did right here, right? Essentially all of them have been broken apart in their respective components, the whole mechanism. And then that leads into the second one, which is what? What is the second? Draw the free body diagram. Yes, draw free body diagrams for the links. Cool. All right. So we have I've already taken care of that, so we didn't have to waste time with my bad drawings and all the confusing lines. So this is all of them right here. All right. The third one is what? Start making equations. So yes, so once the free body diagrams have been properly done, you can start looking at your equations. So create equations for each link. One link equals 3 equations. But there is a caveat to that. That's why there's an asterisk there. Number your equations as you go. Yes, so make sure as you create the equations, so as you create the equations, number them. Indeed. And then once you've collected all of your equations, you put them into a matrix. So once the equations are finished, collect them into a matrix. All right. So that right there is our steps. And so I've already taken care of the first 2 for you, right? The first 2, pretty straightforward. I broke apart the links for you because last time we wasted a lot of time by me drawing them, and we're not going to do that this time. So, and I drew the free body diagrams. Obviously, I did not draw these, so I will not take credit for it, but we're going to start with our first one over here. So I've left space for us to do the equations beneath it. So we're going to start with that here. So let me draw text box, and then we will do this. So link to equations, because once we draw the free body diagrams, we then do the equations, right? So real quick, we're going to look at this free body diagram before we do anything though. So this link should be very familiar for all of you because this is basically the links that we've had in most of our questions. It's just 2 Revolut joints and an input torque Q2. So this one will be very, very straightforward, right? Would you guys agree? This one will be pretty straightforward. We've done this one many times, and we are going to do it again. So, with that in mind, what we are going to do is we are going to do start the first equation. So, right here we have F12 and F32 as our two forces in this diagram. So, the total force equation will be F12 plus F32, right? Is equal to MAG2. So mass, acceleration due to gravity 2. All right? Then, moving on down, we can break it into its x components, right? So the x components are F12x plus F32x is equal to MAG2x, right? Once again, this is the first total equation, and then all we're doing is breaking them into their components. And just so you guys are aware, though, like I haven't said this, but essentially this F12x thing and F32x, those are its components. So I mean, this would be your sines and cosines, but we just write them as F12x because we're not really concerned into it right now, right? Not concerned with writing it as such. F12y and F32y is equal to MAG2y. So is everybody pretty solid on this right here? I mean, this is something we've done now like, 7 times. So I think everyone is probably pretty good on this, hopefully. All right, so x and y components, let me label them as well. And that is, I'll label that as the total. So that's the total force, x and y. Now we have one last one, which is the moment equation. So the moment equation, we have to follow our handy-dandy rule. And so our rule is Rx, Fy minus Ry times Fx, right? This is the base equation for that. So with that in mind, move on down and we start the moment equation. So what we do is we do R12x times F12y minus R12y times F12x, right? This is our first version of it, or our first, so this took care of just this force, F12. So this is the moment forces on F12. So we have the x distance times the y force, the y distance times the x force. Now, move on to the next one, which is going to be the exact same thing except with 32. So R32x times F32y minus R32y times F2x. All right. I'm probably going to shrink the font a little bit. Oh, don't want that. No. What are we doing here? Why won't it let me grab all of it? Okay, this is not going how I wanted it to. Select all. There we go. Oh, come on. Okay, whatever. We'll just have to deal with it. Okay, so now we have to do equals, right? So there's something on the other side, obviously, as we found out from yesterday. I guess I'll just drag this over then. I want to make that better. All right, there's something on the other side, which is I2, and then it's alpha 2 times alpha 2. And then there's something else. It is minus that Q2 term. And the reason why it's Q2 is because we have an input torque right here. And it used to be on this side, but we want to move it all the way to the other side just because we want to keep all the knowns and unknowns separate, right? And so we put it onto the known side, which is I2 alpha 2 Q2. All right. put that over there. So are we all good with that? Everyone understand how we got all of these equations? Okay. Muhammad speaks for the rest of you. So we're moving on. Alright, so that's link 2. Now I need to move to link 3. Alright, so link 3 equations. So this link is a bit more complicated, as you can see. But in terms of forces, I mean, it's still the same thing we've always been doing, right? So we just kind of work with it. So we have to do the total force. The total force equation will help you a lot in determining everything else. So what forces do we have acting on this? So type it into the chat. Which ones are on this? Okay, X and Y, sure, but which specific forces? Like, what are the names of them? Minus F32, I agree. So minus F32. Then where's another one? F43. Yep. Oh, 4-3. Yep. And one more. F5-3. Agreed. AG3. You got something, Jackson? You writing a novel? Are those forces always given? What do you mean that are they always given? So essentially, if you look at this from this original diagram, you have to determine them. This diagram will not be given. Essentially, you'll get this, and you have to go, oh well, F43 is right here, F23 is right here, 1-2 is here, and then this force is an up and down force because it's a slider, right? And then there's one more here as well. There's 5-1 and 4-1, but so you have to look at this and know where they're at. Does that make sense? Yeah, we're getting there. The rolling contacts have their own forces as well. And the rolling contact in this chapter, they just kind of throw you into the deep end because we've talked about them quite a bit, but in this chapter it doesn't change much really. All it does is you just have to make a free body diagram of the roller and see where the force is going, but it's no big deal for us. Alright, so next up, right? So next up, what's our next equation, right? We have to do which type of equation? Anybody? The components. Agreed. So we have our x component equation, which would be minus 5, 3, 2, 3, 2, x plus 5, 4, 3, x plus f 5, 3, x equals mag 3x. Right? And then we have minus 5, 3, 2, y plus f43y plus f53y is equal to mag3y. So same thing as usual, right? There's no tricks to this one, right? There was nothing on here that like got rid of an equation. Simply because this thing, so as this part turns, you would think, oh, well, this is always a straight up and down force. Well, not quite, because essentially, yes, while its force is always going to be perpendicular with this like beak, right? It's always going to go straight up and down with respect to this beak. as this thing turns, its x and y components change, right? So essentially, if this beak was completely like flat, it would have an 100% y component, right? Essentially, but as it turns and the beak starts, basically hitting a little more into it, the x and y components change, right? Essentially, the angle from the horizontal has changed, so it has a different component. Does everybody kind of understand that? So this one does have x and y components. That's what I'm trying to say. It has both. If that was a little long-winded. All right, so now we have to do the moment equation. So moment equation. So for this one, we have 3 forces. I think this is the first time we've actually had to do 3 of them in a moment equation, and you have to do it for all of them. So let's go ahead and get started. So the moment equation, we have minus r 32x times f 32y plus r 32y times f 32x. That makes up our first one, right? And we had to flip the sign, if you recall, because f32 is a negative up here, right? And then we move into the next one. So let's do 4-3 now. So we have r 4-3x f 4-3y minus r 4-3y times f 4-3x. Once again, sticking to the script, nothing new here. And then we have to do the last one, right? And the last one is the same, it follows suit, which is r 35x times f 35y. Like I said, I always flip, I'll continuously flip these, but I think the reason why they have it that way is flip, make sure you understand that one is a force and one is a vector going to it. I don't know. I just know that they're linked together in a way, so I don't really. If you flip it, you flip it. I'm not too concerned with it. 5x, and this is now the third force in here, and it must be equal to I3 times alpha. Alright. And try not to take up too much space over here. Oh yeah, we are already there. That's alright. I'll just do this. Hopefully everyone can follow. Okay, so is everybody good so far, right? So we did total x, y, and then the moment equation, which is this one, moment. So pretty all good so far. I think we've done this enough times that you guys are probably falling asleep at the keyboard. But there's a reason why I do this. It is for your benefit in the long run. I promise. So now that we've done this one, now we have to do the rolling contacts. So that is the next one. So the rolling contacts. So we have both of them. We're going to start with 4, as is tradition, go in order. So link 4 equations. So what forces do we have acting on this one? Looks like we have negative F43, because remember that is the force from the pin connecting it to link 3. And then we have F14. F14, as you recall, is a force, it's essentially it's a resistance force. It's the normal force, right? The normal force of the ground. So if we go back up here, which I will do really fast, as you can see, this right here is how it's laying down, right? So essentially our force, F14, is resistant into that, right? It's essentially pulling back this way. It's the same thing we had with the other. I don't think we haven't had a rolling contact, have we? Oh, we haven't. But if you look the type of contact we have here, so I can't really, I'll just do it, whatever. It'll be okay. So essentially how this thing is laying, it's kind of angled against it, which is why your force of 1-4 is like sort of like this, right? Because you're on a curved surface. So it's sort of like that. That's how F14 looks down here, and that's the reason why it is like that. So now that my text box is gone. Alright. Link for equations. So we should start out the same way that we always do, right? And how we started out the other ways was X and Y. So, or total force, sorry, negative F43 plus F14 is equal to MAG 4. Right? Everybody good with that? And this is once again the total equation. Now let's move down, do the x components, which is minus F43x plus F14x is equal to MAG4x. Same thing with the y, minus F43y plus F14y equal to MAG4y. All right. So, now, now what we have to do is, we have to do this next part, which is the moment. Now, real quick though, because this is a rolling contact, we have to talk about something. So, essentially this wheel is free spinning, right? Would you guys agree? Like it is pinned, only pinned here. Is that fair? Fair to say? It is pinned at this point and it's just allowed to freely spin by whatever contact it comes in. Does that make sense? Looking for a yes or no here. Yes. Okay. So if this pin holding it in place is all it's doing is holding it in place, is it contributing? Is the contributing force inside of there, the internal pin force, is that contributing to a moment in any way? So think about it. So essentially, is that contributing to a moment, this pin, or is the only spinning force that we have its contact with the ground? Yes, it is the contact with the ground is what is causing the moment. So the internal pin, all it does is hold it in place, right? It's holding it in place. It is not causing this thing to spin, right? Does that make sense? So think about it this way. Think about how wheels are connected on like a shopping cart or something. You know, it's like pinned through like some casters or some wheels. And essentially what you do is if it is not contacted with the ground, so let's say you lifted the shopping cart up in the air, there are forces being pulled on those pins, right? Because gravity's pushing down on it. But you notice that the shopping cart wheels are not spinning. But as soon as you put it on the ground, it is spinning, right? And start moving it. It's because the only forces applying to a moment, a spinning of that circle, is the contact, right? So, in that respect, we now have to, we basically don't take F43 into account, right? F43 is not part of the moment equation. It was only part of the force X and Y's equation. So, moment equation. And also, there's a reason for that is because the more scientific reason is that F43 takes place exactly on the center of gravity, and therefore its moment is 0. But anyway, that's the more scientific reason. But I was doing the shopping cart. You guys like the shopping cart? But yeah. So, in my neighborhood, if you have a shopping cart, it's usually like not at the store. It's like down the street somewhere. But at any rate. So, what that means is that we now have to do only F14 in the moment. So, real quick, R41x times F14y minus R41y times F41x. You got something for me, Jackson? This is link 4 times alpha 4. Did you have something or no? We will wait at. You're gonna bring back up the shopping cart conundrum? Oh, okay. Was it like you said? It's a deep rabbit hole. Okay, so essentially, were you gonna bring up that my shopping carts in my store get stolen, or was it more based off of like the actual physics of shopping carts? Which one was it? But we're not gonna go down your rabbit hole, right? Alice. But I was just curious as to which one. The idea of a shopping cart. Oh, man. Okay. Anyway, we're moving on. I don't know what that means. What is it, a statement? Anyway, so a shopping cart is not just a shopping cart. It is a statement. So moving on to link 4. Or link 5, right? So this is all our equations. Let me go ahead and label these. Oh, man. See, you remind me of another Jackson. I've taught 2 Jacksons at this point. The other Jackson, he was while we're just talking about it, he's a funny dude, but he used to like freak out about the smallest things and like not like freak out, but like he would like, for example, everybody know the term centripetal force, right? Is that a real physics term? Anybody? Is that real? So Jackson, every time I used to bring up centripetal force, which was just reading it out of the book, right? It was just part of the notes. He would cringe because and then he would actually cringe in the classroom, and then eventually I stopped and I said, "Okay, Jackson, why are you cringing? Like, what is wrong with you?" And he goes, "Centripetal force is not a real thing." And he was serious. And by the way, he's actually correct. It is an observed force. It is not actually a real force. It is an observed force. So, but he basically, every time I said centripetal force, he cringed because I called it a force when it wasn't one. So yeah, it was, he's a funny guy, man. He's from that town in southern Illinois that had like the yodeling kid. Is that Harrisburg or something? Yeah, he's from there, I think. But he's a funny man. Smart dude too. All right, so moving on. Link 5. Sorry for the people that have to watch this years from now and go, "Why are we talking about a yodeling kid?" Look up shopping. So John, if you're in here, can you look up shopping cart theory for me, really quick? Give me the synopsis later. Alright, so link 5 equations. Oh my god. So then we're going to do the exact same thing that we did with the other ones, right? So, minus F53 plus F15 is equal to MAG5. Is that right? Yeah, okay. And then we do it again, minus F53x plus F15 x is equal to MAG 5x. So, okay. I might bring this up at the end because that's hilarious, but I'll read it in a minute. So, minus f53y plus f15y mag5y. Okay, so does everybody understand? Once again, all we have done is we've done the total, we have done the x, and we have done the y once more. By the way, every single person in this class is looking up shopping cart theory, and this is the most Google searches that it's had in years. Like, holy crap, shopping cart theory is really picking up steam today. So, let's move on to the moment equation, shall we? So, moment equation, it's the same thing as the last one. The F53 is not part of it. So, we do the same thing we did before, which is R 15x times F15y, or what am I doing? R 15y times F15x to I5 times ALF5, right? And let me parentheses these off. But I missed something, as per usual. There is a plus Q here, plus Q5. 5, right? All right, so is everybody good here? Does everybody understand? Junlin, do you have something? No, because Q5 is something we know. We don't know it, and we want to find it. It's the output. So we're keeping it over here for now, right? Keep it over here. All right, so let me go ahead and knock that one down. All right, so this is what we have so far. This is our handiwork, right? I really should have made this bigger for everything else smaller, for the matrix to come. But that's okay. So now that we have that, so let me go ahead and 2D shapes. Let's get some X's over here. As you create the equations, number them. I did not do that, so we're going to go back and do that really fast. So once again, we have 1, 2, crap. This one got screwed up because I made it too small. I'll add another text box just so we can do that really fast. R12x plus F x plus, I'm sorry about that, R23x times F23y minus R23y times F23x is equal to, so this is I2 times ALF2 minus Q2. Of course. There it is. So that is, wait, what? Oh, I know what it is. It's because this text box is over here. Oh, I'm so dumb. Yeah, my fault, guys. So we'll just have to probably remember. I can't believe I'm doing this. Wow, I'm so dumb. Why am I so paint challenged? All right, minus R23y times F23x. We're moving down a line. So we did the first one, then the next one, and then moving down. So this is I2 times alpha 2 minus Q2. All right, it works. Huzzah. So this right here, equation 3. This is 4. This is 5. This is 6. Right? And this is 7, 8, 9, 10, 11, and 12. All right. So now we have to count the number of unknowns we have. So I'm going to do that in the upper right corner up here. So we're going to... So this is unknowns. So unknowns. So we have f12x, f12y, f23x, f23y, f34x, f34y, so f34x, f34y. Then we have f14, f14x and y. Then we have f53, f53x, f53y. We have f15x, f15y. So what do we got here? What are we working with? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we have 12 equations. Wait, what was that? Minus question mark? What am I missing? Are you asking, so for the minus F23, those aren't different forces. They're just a negative in front of it. They're the same force. So you don't need to find both of them. Yeah, one of them is just the equal and opposite version of the other one. So this is what we got, right? So we got all of these. So let me make sure that I'm on the right track. F15, F35. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 13. So it's 13 unknowns. And we have 12 equations, which means we need one more. I forgot to put... there is actually another one, which is our Q5, if you guys recall. Our output torque. I forgot to put it up there. So we need one more equation. One more equation. And so, this isn't something I'd expect... basically, this isn't something that I would expect heavily from anyone. Our questions will not be this complex on the exam or your homework. But, essentially, the last one, they made up an equation based off of this slider. And so, I'm going to explain it here in a second. So the equation for this slider that they have created makes a lot of sense, actually, if you think about it. At least, hopefully, that's the way that they actually meant it. We'll see. But essentially, it is the following. It is cosine of, I wish I had theta here, so theta 3. So T3 is theta 3, just so you guys know. Oh, no, theta P. So theta P times F53x plus sine of the exact same thing times F53y equal to 0. So essentially what they said is that inside of this slider, the summation of the x and y forces added together must be 0, right? And that does make sense, because if one of the forces actually wasn't, the forces kind of have to be in line, right? Because so, for example, as let's say the y force is now at like, I don't know, 100 and so let's basically in this slider, I was gonna give you like a really hard to, I'm trying to think of a better way to put this, but essentially the summation of the x and y forces inside of that slider have to be 0, because essentially it's sliding, right? And so if one of them was greater than the other, it would not do it. You see what I'm saying? It would like I don't know, it'd break out or something. I don't know. I'm trying to think of like a really good way to explain this, but they don't really explain it very well either. Here, I'll read you the exact definition of what they say, why that equation makes sense. It says, additional constraint includes the condition of perpendicularity of force F5 in the slot. So, okay, now this is going to make a little more sense, I guess. So, essentially what it's saying is that F5 must always be perpendicular, right? So right now, F5 is running like this, right? Which is perpendicular to the slot. Does that make sense? Because it is a slider. So it's running like that. As this thing turns, so for example, this thing could go down here, and then this slot could become a little more straight, right? You see what I'm saying? Like essentially this whole thing could move a bit, and then the slot is no longer at its same location, and therefore it's going to change the direction of this part right here, could move up a little bit, and therefore it's no longer as angled as it is. And so it says, since the position vector RP is along the slot with a unit vector RP is perpendicular to the force F3. Perpendicular condition can be obtained by requiring that the inner product of a unit vector UP along RP and FP be 0. So essentially, this is basically what the saying is that this force always has to be perpendicular. What? Oh, I didn't give my text box. I actually didn't do it. So it's saying that this force is always going to be perpendicular, and if it's always perpendicular, that means that the sine or the x and y components must be 0, added together. Does that make sense a little bit? So that's our last equation, which I don't know why that didn't stay, but you know, as usual, things go wrong. So let me zoom back in here. Cosine TP times F53 plus sine, straighten that out, theta P times F53y is equal to 0. And so that is our last equation, and we are going to label that as such, which is 13. So if we now, I'll put that on the other side. So if we now then switch to the matrix, which is the last part of this, which is the most brutal part, I agree. Now I really wish I would have found a way to do a better matrix, but I guess I can't. Actually, wait, I have a great idea. Give me a second. We're going to work this up right now. Anybody see where I'm going with this? It's about to be brilliant. That is not exactly where we wanted that, but that's okay. We'll move it a little bit. Alright, so I need to move probably a little more that way. Cool. So now we do another one, which will be our unknowns category. And then we do our last one, which is a slightly bigger one. You guys will be deeply impressed with this in a minute, I promise. Alright, so boom! You guys like that? Dude, how smart was that? Yeah, dude, that's A+ work right there. All right, so now we can fill in our unknowns right here. So we're going to do that. So how we're going to fill them in is we're going to take it from our unknowns list. I'm just going to do it from my head, but f12x, f12y, f23x, f23y, f34x, f34y. I might have to make these smaller. Not that small, probably. Still probably not that much. Might insert my own here. Whatever. Hopefully this will be good enough. So f34, f14, y, or x, f14y, and then we have f35x, f35y. I guess I'm gonna have to do it. Alright. Which is really lame because now it's like barely gonna take up the whole thing. Why can't I do my own there? Anyway. Anybody have an idea? And it's f15x and f15y. And then the last one is q5. So I'll just move this one down a little bit, I guess. Alright, so that is our lineup, right? And then for our other ones, this one's going to be also done for my head. We'll see if I can manage this one. So this one, the first one will be MAGTX. Yeah. And it'll be MAGT2Y. And then the next equation will be I3 alpha something. I think that's what it was. I think it was I2 alpha something. Yeah. Sorry, I'm trying to remember these. So I2 times alpha 2 minus Q2. All right. Then it's M. Oh yeah, that's right. Sorry. I keep forgetting to do that. AG2X, M3, AG2Y, and then it's I3 times alpha 3. And then it's M4, AG4X, M4, AG4Y, and then it is I4 times alpha 4, and we're getting there. M5, AG5X, M5, AG5Y, I5 times alpha 5. And then 0. And I forgot an equation over here, as per usual. So I will... Oh, it didn't write it anyway. It's right here. This right here should be Q5. And then right here should be 0. Alright. So now that we have all of that written in, all of our equations, we can now start filling it in. I'm just going to fill it in really quick. If you have a question, you can stop me, but I'm going to fill it in as fast as I can. So I'm going to do a text box for the whole thing and hopefully see if I can just fill it in. So they won't be spaced very well. I'm just going to warn you now. But yeah, I'll have to zoom out a bit. Let's do 20. That's better. All right. So f12x, there is 1 in the first one, so that's a 1, 0, 1, and then 0, 0, 0. Although these could probably be bigger. Not that much bigger, though. All right. Although I'd have to space them out more. I wonder if I can tab them. I guess the spacing's not really that important. It's just gonna bug the crap out of me. So, I might just do it as small as, I might just do it and then hopefully you guys can follow along, right? Because we need to hurry this up. Yeah, okay, never mind. So I'm just gonna do it all in a very short line. Sorry about that. 1, 0, 1, 0, 0, 0, 0, 0. And there should be a total of 13 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So one more. All right. And then the next equation, we have f12y, so it's 0, 1, 0, 1, and then 1. Like that. And then we move on to the next one. It is, we have an f12x, which we do, which is a minus r12y. And then we have an f12y, which is an r12x. And we have an f23x, which is a minus r21y, minus r21y. Wait a minute, whoa, no, I messed that up. It is a, r23y, sorry. 23y. And then it's in r23x. And then it is none of the other things. So that's 4, so I need 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yeah, like I said, it's going to be really, really bad. So prepare yourselves. If I just hand wrote it in there, it'd probably be better. But I didn't want to do that to you. Honestly, I actually think I'm going to. I think this is really bad. I'm actually going to do that. I'm going to handwrite it in there. Sorry, guys, for taking more of your time. But, so 1, 0, 1, 1, 2, 3, 4, 5. All right. Sorry. 0. Oh, man. 0, 1, 0, 1. 10. Okay. And then the last one, it was R23 minus R23, or minus R21. X R21y minus R23x, and then it was R23y, and then 0 is the rest of the way. Yeah, this is gonna be rough, no matter what I do. All right, and then then we move to the next one. So f23x. So it should be 2 zeros here. So 1, 2, and then we have f23x, which is -1. Then it should be a 0. Man, why am I so bad at drawing that? 0, and then it should be +1 because we have an f4. Oh, wait a minute, there's more than that in this one. Okay. So negative, let me check the list here. 34x comes after that. Yep. So there should be a 1. And then what comes after that? So 35 should be, so that's the x. Another 0 here is the y. And then there should be 2 more zeros. And then there should be a 1. And 0, 0. Yeah. We are going to end up in rough shape here, no matter what I do. Alright. Let me continue. So we have, once again, 0. Yikes, dude. Alright. And this won't be 0, 0, 0, negative 1, 0. And then, so negative 1, 0, 1. This should be 1 as well. And then it's a couple zeros. Yeah. We're not even going to have the same number of zeros in each category, it looks like, because of how I'm drawing it. But hopefully everyone's kind of figuring out what I'm doing. It's really hard to see, I know. Honestly, this is... Why don't I just do this? Like, straight up. I don't really... I was, like, trying to show how to actually do it, but it's... Hopefully we can go through it easier like this. I don't know why I've been doing this. It's what you guys are in here to tell me whenever it's not working. You're supposed to type this in and say, this ain't working, chief. And then this is where I make the adjustment. Everybody's half the way asleep already because of what I've been doing. Sorry about that. Just drop that in down there. Alright. So, we were on the right track. As I said, 1, 0, 1, the rest zeros. 0, 1, 0, 1, rest zeros. R2, 1y, R2, 1x, R2, 3y, R2, 3x. Then it was 0, 0, negative 1, 0, 1, all the way down. And then there was a 1. Because remember this equation, so we started to get to this equation. The 5, 3 is a little further down than before. And so you have to go all the way down here to put it in. So still, make sure you follow your rules and get all the way down to the bottom. Then we do the same thing. It's the inverse of that one. So there's a 0 here, negative 1, 0, 1, 3 more down, 1, right? So that's the cool thing about the x and y equations, that they're essentially, wherever there was a 0 before, there is now a 1 or a negative 1. So, and the pattern stays the same. Alright, and then right here, R32y, which we grabbed from the moment equation. So the moment equation right here. So R32x is right here, R32y is there. So it shows up first right here. And then for y, we have a negative 32x, which shows up there. For for f32x, which is, or for f43x, sorry. 43x. Oh, where's it at? Oh, it's because it got cut off. Anyway, so for f43x, you have a negative R434y. For an f34y, you have a positive R43x, and then 2 zeros because we do not have any 1 4s in this one. I don't think. Nope, no 1 4s. And then we move on to 3 5s, which is the same thing. You plug them in over here. And then we're back to the x and y equations, which are these two. So, obviously, a bunch of zeros until we get to 4, 3. And then you put a negative 1, 0, 1. Zeros the rest of the way, right? And then, same thing. Fills them in. And then R41x, here, R41y comes from here. R41x comes from here. So these are the coefficients of it. And this is the 6th one in, and if you go 1, 2, 3, 4, 5, 6, right? 7, So yeah, the 7th one in, R41Y, is right here. So if you go to F14Y, R41X is in front of it. Although I think I might have them flipped. I had them flipped, I think. But essentially, just as long as you're matching columns with rows, you should be good. And then you put the zeros in the rest of them. And then the same thing, we're back to X and Y equations. The 5-3 starts all the way down here, so 5-3x has a negative in front of it, 0, or -1. No F3y's, and then we have an F15, which is here. Now we inverse it because this is the y equation. There was a 0 here, now there's a -1, a 0, and a 1. So the pattern just shifts 1 over. It's a shift of 1. And then we do the moment equation, R51, R51x, which comes from here, just like all the other ones. So R51X, yep, and R51Y are here, but I'm a little confused about this one. Why there isn't a 1 for the moment here. There should be. I think this should be a 1 right here. So make note of that. It's because this right here, there is a Q5 in our equation, and Q5 is the variable, so this should be 1. Does everybody understand that? I think that's a mistake, but I'll make sure it is. And then the last equation, which was our equation 13, which is way up here, is we have the coefficients of F35x and F35y, which in this equation, we have cosine theta p and sine theta p. So if we go back down to our matrix, cosine theta p and sine theta p show up in the columns for F35x and F35y, which are right here. Yeah, sorry about that. Getting to that one was a little hard. I should have just done this for the beginning. So, if you have questions about setting up matrices, let me know. But they're really not that bad as long as you follow the rules of moving from column and rows down. Besides that, yeah, I'm going to go ahead and end the show, and then you guys can get out of here.